Greetings yet again. This time we're going to be looking at AQA's GCSE Maths paper, Foundation tier, from November 2017. It's the paper 3, which is the calculator paper and the last one of the series. And so let's have a look at these questions, beginning with, of course, question 1. Question 1, we have to circle the cube number. And so what this means is, one of these numbers equals a whole number multiplied by itself 3 times. So there are a few ways of doing this. One way I'd suggest is just looking at the numbers. Each one begins with a 1 and ends in zeros. And so if it's a 1 ending in zeros, that means it's going to be 10 multiplied by something. So one thing we could try as a hunch, as a guess, is what would 10 cubed be? Is 10 cubed in the list? It's a calculator paper, so we may as well be using it. So 10 to the power 3 is 1,000. And so 1,000 is a cube number because it's 10 cubed. And so that tells us already that the cube number in the list is 1,000. So we can stop looking because we've got our answer already. So the one we need to be circling is 1,000. Another way we can think of this is that if a number is a cube number, it will have a cube root, which will be a whole number. So what we could do for each of these numbers is take the cube root. Now, I think this way is a bit more complicated, but even so, I'm going to mention it. Now, the cube root on your calculator, if nothing else, it's a good excuse for me to tell you about the cube root function. The cube root of a number looks like the square root symbol of a little 3 outside. So we can take this cube root of each number. So what you do is you press Shift and the square root button. This gives you the cube root. So if we try 100, the cube root of 100 isn't a whole number. It's 4.64 something. But if you were to try the cube root of 1,000 on your calculator, you would find that that would be 10. Which is a whole number. And so thinking of it that way, if a number is a cube number, it will have a whole number cube root. If 1,000 has a whole number cube root, the cube root of 1,000 is 10. So that tells us that 1,000 must be a cube number. Moving on. Question 2. A fair dice is thrown once. Circle the probability of getting a 2 or a 3. So we're not bothered if it's a 2 or a 3 here. So a dice has 6 sides, and a 2 or a 3 account for 2 sides of a dice. So 2 sides of a dice out of 6 have a 2 or a 3 on them. So because it says or, we're not really bothered if we get a 2 or a 3. So 2 out of 6 sides have a 2 or a 3. And so as a fraction, that means the chance of landing on a 2 or a 3 would be 2 out of a total of the 6 possible options it could land on. 2 out of 6, which is what we have for our second option. So we circle 2 over 6. Question 3, we need to circle the decimal that is greater than 1/5 and less than 1/4. So what we could do, because we've got decimals here to compare, what I'd suggest doing is changing each of these fractions here into a decimal. And the way we can do that is to type in the fraction on the calculator, press equals, then press the S arrow D button. And so 1/5 is the same as 0.2. Now if you look here, the decimals and comparing it to, all have 3 decimal places. 0.2 only has 1 decimal place. So to make it 3 decimal places, I can include some other digits after the 2. But after the 2 is literally nothing. Nothing's there. Nothing in maths is 0. So I could put 2 zeros after, so it's 0.200. And so if I have a look what we've got here already, it says circle the decimal which is greater than 1/5. Well, 0.152 certainly isn't greater than 0.2 because 200, the decimal part, is bigger than the decimal part of this number. 200 is bigger than 152, so that can't be one of the options. And it can't be this one either. It says circle the decimal that's greater than 1/5, not equal to it. These two are equal, so it can't be that one either. Finally, if we have a look at 1/4 and change that into a decimal, 1/4, let's go back and edit this, 1/4 equals 0.25. So again, to convert that to a number with 3 decimal places, we can include an extra 0. So which one of these 2 remaining options is less than 0.250? Well, 251 is bigger than 250, so we know for definite it can't be this one. The only option we'd have left to go for, the only one it can be, is 0.215. And so this is the one we circle. And question 4, what is a litre a unit of? Well, this one should, I'm hoping, be fairly straightforward, but just in case, I'll go through and just explain each of them. Area is nothing to do with litres. So area would be meters squared. Something like square meters or square centimeters. Density is what's known as a compound measure. A unit of density would be something like grams per cubic centimetre. It's a unit of mass per unit volume. Mass? Certainly not. Litre isn't a unit of mass. Mass is something like kilograms or grams. Litre is a measure of capacity. It's a liquid unit, so a litre is a measure of capacity. It tells us, for example, how much a bottle of water can hold. So it's a measure of capacity, so that's all we need to circle. Question 5. We're told that 2.5 kilos of carrots cost £1.70. We also need to work out the cost of 3.25 kilograms of carrots. And so for this one, what we need to be doing is just writing it down as a relationship. So 2.5 kilograms of carrots will cost £1.70. There's a few ways of doing it, but I think the easiest way, or the easiest way I'd suggest, is to find the cost of just 1 kilogram. Once you know the cost of 1 kilogram, we can just multiply that by whatever we need. The question now is, to go from 2.5 kilos down to just 1 kilo, what can I divide by? Well, any number divided by itself gives us 1. And so what we need to do is divide the weight of carrots by 2.5. 2.5 divided by 2.5 would give us 1. But to keep the balance, if we do that to one side of a relationship, we need to do it to the other as well. So if we divide the cost by 2.5, that will tell us the cost per kilogram of carrots. So £1.70 divided by 2.5 is 0.68, so 68 pence per kilogram. But of course we don't want just 1 kilogram, we're wanting 3.25 kilograms. But once you worked out the price of 1 kilogram, which we have now, the rest isn't too bad. And so 3.25 kilos, which is what we want to work out, what we need to do is go from 1 kilo up to 3.25 kilos. And so we do that by multiplying by the amount we want. 1 multiplied by 3.25 gives us the 3.25 kilograms we want. But the same way as what we did before, what we do to one side, we need to do to the other as well. And so, if we've multiplied this side by 3.25, we also need to multiply the cost by 3.25 as well. And so the cost of 3.25 kilograms of carrots will be 0.68 multiplied by 3.25. And that comes to £2.21. That's our final answer, £2.21. Question 6, we're told that Gina's making a sandwich, so she's got a choice of either a bread or a roll, then a choice of either ham or cheese, and then a third choice of either salad or pickle. So it says here, list all the possible sandwiches Gina could make. The first one's been done for you. So this one is bread, ham and salad. So if we're systematic, this question isn't going to be too bad. So we could have bread, ham and salad, or we could have bread, ham, instead of salad we could have pickle. So let's think about what else we could have. So we've tried everything with bread and ham. Now how about doing the same, but instead of having bread and ham, we can do bread and cheese. So we could have bread, cheese and salad, or we could have bread, cheese and pickle. So we've done both options with bread and cheese. We've done both options with bread and ham, which we did first. So we've done everything we can for bread. The next thing is to do exactly the same, but this time with rolls. So what we could have is roll, ham, salad. It's now going to be exactly the same, but instead of a B at the beginning, we're going to be doing it with R instead. So instead of using bread, we're going to use a roll. So RHS, RHP, so we've done roll and ham. Now we can do roll and cheese. So roll, cheese, salad, and finally the other option is roll, cheese and pickle. So there's actually 8 different combinations there. One that's been given to us, plus another 7 which you have to find. So part B, it's asking what fraction of the possible types of sandwich have cheese and pickle. So let's just scout for cheese and pickle. So cheese and pickle means which ones have got C and P in them. That one does, and that one does. And so out of these sandwiches, only 2 have cheese and pickle, but that's out of a total of 1, 2, 3, 4, 5, 6, 7, 8. And so the fraction that have cheese and pickle is 2 out of 8, which, if you want to, we can simplify down to a quarter. Now, for probability, simplifying down isn't as big an issue as it normally is. So we can leave it as 2 over 8 if we'd like, or if you can, or if you want to, if you've got a calculator, I suppose you may as well simplify it down, but it doesn't matter as much. You'd still get the marks either way. And so 2 over 8, or 1/4. Question 7 we've got to have a look at now. We've been told that ABC is a right-angled triangle, and we've been given point A, point B, and we're told that point C is a point on the line y equals 4. So I'm just going to dive in and have a look at point C. Now the line y equals 4 is a horizontal line which cuts the y-axis at 4. So this line is going to look something like this. With a straight line going across at y equals 4. Looking at the other points, we're told A is at -3, -2. And so A is fixed. It's -3, -2, which is down here. B is also fixed at 1, -2. So A is down here. And so what we can do, may as well do, is just mark these in with a cross. But we're told that C is a point on the line y equals 4. Now, we're not told exactly then where C is. But what we have been told is that ABC is a right-angled triangle. And so that's going to help us because we know one of the angles must therefore be a right angle. And so what we can do first of all is take these 2 points here from A to B, do a straight line through. Now the right angle might be at this side, in which case this angle at A is going to be the right angle. And if that's the case, then that's one possible option for drawing triangle ABC. So in this example, our version of C is up here. And the right angled triangle, the right angle of the triangle, is down in this corner. So that's one possible option. Another possible option is, again, if the right angle is somewhere different. So I'm just going to quickly sketch in this same triangle as what we had here. So one point was here, one point was here. And so we had, this was A, and this was B. Now, like I'm saying, we could have a right angle in a different location. I'm not saying draw two triangles, I'm just showing you both possibilities of how you may have drawn yours. So the other place the right angle could have been is if the third point, if C were touching the line y equals 4 up here. And if it did, in that case, the right angle of a triangle would be down in the bottom right corner. So in this case, the right angle would be down here. So there's two possible options there. One option is here, A, B, C. And the second option is the first one I drew, which is back here with A, B, C looking like this. So obviously just draw one triangle, either this triangle or that one. Doesn't matter which one you actually draw. Part B, you need to be working out the area of triangle ABC. So we need to remember the formula for working out the area of a triangle. And that formula is that the area of a triangle is we do the base multiplied by the height, and then absolutely we must remember to divide by 2. So area of a triangle is base times height divided by 2. Now this grid is a centimetre grid, which means that each square is worth 1 centimetre. And so looking at the bottom bit, the base of this triangle, how many squares along is it? Well, hopefully you can see that it's 4 squares. So the base is 4. And the height of this one, how many squares high is it, we can work out again by just measuring or counting the squares. From the bottom at A all the way to C, it's 1, 2, 3, 4, 5, 6 squares high. So that's 6 centimeters high. So it's 4 times 6 divided by 2. Always remember, with a triangle, divide it by 2. And so if we try this on our calculator, 4 times 6 divided by 2, we should get that the area of this triangle is 12 square centimeters. And so that's what we put on our answer line. The answer is 12. That's just the second triangle we drew. Question 8. Complete the number machine so that Q equals 7R minus 12. So what we can do here is think about what's happening to R according to this formula. So if we start with R, think what's the first thing that happens to it? The first number that R encounters is the 7. 7R means 7 multiplied by R. So the first thing is R's being multiplied by 7. After being multiplied by 7, we subtract 2. And the net result of all that is that all equals Q. And so these are the steps we can fill in. So first of all, R's multiplied by 7. Then we subtract 2. And the output of all that is Q. Part B, different number machine, and again we need to write down the output Y in terms of X. And so this time again we're starting at the beginning, we're starting with X. So the first thing that happens is X, we're going to add 5 to it. So if you add 5 to X, we'd get X plus 5. But then after adding 5 we're going to multiply by 3. It's not just multiplying the X over 5. This means multiplying the whole thing by 3. And so what we can say is, it's X plus 5, all of it, multiplied by 3. So there's two ways of writing this down actually. One way is, if you multiply the whole of more than one thing by 3, what we could do is put the thing we're multiplying by 3 in brackets and put the 3 at the beginning. And so that's one option. We could say that Y equals 3 brackets X plus 5, or equally we could just expand these brackets out. If we multiply X by 3 we get 3X, and if we multiply the 5 by 3 or 3 by 5 we'd get 15. And so we can say that either Y equals 3 brackets X plus 5, or we could say Y equals 3X plus 15. Either options for the answer would be accepted. Question 9. This really is a truly excellent question. I'm sure you'll agree. A farmer has 580 eggs to put into boxes. The boxes come in 3 different sizes. So you've got boxes of 20, boxes of 12, and boxes of 6. So he wants at least 10 boxes of 20 eggs, at least 15 boxes of 12, and at least 25 boxes of 6. And so we can work out how many eggs this is. So he wants, or has boxed up at least 10 boxes of 20, which is 10 times 20. And we know that because it says he wants at least 10 boxes of 20. Another thing it says is at least 15 boxes of 12. So that means at least 15 boxes of 12, which is 15 times 12. And then finally, it also says that he wants to have at least 25 boxes of 6 eggs. So what we can do is use our calculators to calculate this grand total. So 10 boxes of 20 plus 15 boxes of 12 plus 25 boxes of 6 we can work out here. So you can put it into brackets if you'd like to. You wouldn't need to actually, but if it makes you feel safer or more comfortable, you can. So 10 times 20 plus 15 times 12 and plus 25 times 6, we'd get 530 eggs. And so that's using 10 boxes of 20, 15 boxes of 12, 25 boxes of 6. But it's saying here that he fills 54 boxes with 80 eggs. So let's see how many boxes we've got so far. So far, 10 boxes of 20 plus 15 boxes of 12 plus 25 boxes of 6. Let's see how many boxes that comes to. So 10 plus 15 plus 25, that's 50 boxes. So 25 boxes of 6, 15 boxes of 12, and those 10 boxes were boxes of 20. So boxes so far, that's 50 boxes. But it says here he fills up 54 boxes with 50 eggs. So he's going to use that's 50 boxes, and he's going to use 54. So he's going to use another 4 boxes for the remaining how many eggs? Well, so far, according to this, that's enough for 530 eggs. Because we worked that out earlier. So far he's accounted for 530 boxed eggs. But it's saying here that he's got 580 eggs. And so how many eggs does he have left? If it's 580 eggs he's wanting to box up, and this takes care of 530, he's going to have another 50 eggs still left. 580, take away 530, 50 eggs left. So it says that he fills 54 boxes with the 580 eggs, so there's no wasted space. And so there's 50 eggs, 4 different boxes. Box 1, box 2, box 3, box 4. So how could this be done so that he fills the other ones completely, filling 4 boxes with 50 eggs? So how could this be done? There's no way of doing this apart from just trial and error, really, to be honest. But if you used 1 box of 20, another box of 12, another box of 12, so 2 extra boxes of 12, and then finally a box of 6, that would come to a total of 20 plus 12 plus 12 plus 6, which is 50. And so those other 50 eggs could be 1 box of 20, could have another 2 boxes of 12, and a final 1 box of 6. So these are the extra 4 boxes. So now let's compare what we had to begin with. So boxes of 20. Well, to start with, we had 10. He wanted at least 10 boxes of 20. So he got those 10 boxes to begin with, plus an extra 1 box of 20 up here. So 10 plus 1, that's 11 boxes of 20. Boxes of 12. Well, to begin with, up here, like the farmer said, he wanted at least 15 boxes of 12. But these 4 extra boxes, for those other 50 eggs, we need an extra 2 boxes of 12. And so 15 plus these extra 2 comes to 17 boxes of 12. And finally, boxes of 6. To begin with, he said 25 boxes of 6 at least. So those 25 boxes of 6. But then from those extra 4 boxes, we can see that we needed another 1 box of 6 at the end. So 25 boxes of 6 plus 1 extra box of 6 would give us 26. And so those are our totals. And so the working out has gone a bit further than expected, but I'll just box off the answer so we're not in the way. Obviously in your exam you'll have more space than here. So boxes of 20 is 11. Boxes of 12, there would be 17. And boxes of 6, you'd end up with 26. Not the easiest question, but that's question 9 done. And I'm sure you'll agree that was pretty exciting. Question 10. Megan says, if you add any 3 multiples of 10, the total must be a multiple of 10 and a multiple of 3. Is she correct? You must show your working. So it's a 2-mark question. Your first mark will be for correctly saying yes or no, with another mark needed before saying yes or no for a correct calculation which backs up your correct answer, whether it be a yes or a no. So you can't just guess yes or no and get 1 mark. So 1 mark for a correct calculation or example, then 1 mark for a correct conclusion of either yes or no. So let's see. Multiples of 10. So that just means numbers in the 10 times table. So we have 10, 20, 30, 40, and so on and so on, 50. So she's saying if you add any 3 multiples of 10, the total must be a multiple of 10 and a multiple of 3. So let's pick these 2 here. 10 plus 20 plus 30. So 10 plus 20 plus 30 would equal 60. And 60 is a multiple of 3 because 60 is 3 times 20. So a tempting thing and an easy mistake to make is to say, yes, she's right, but actually she wouldn't be. If you were to carefully pick out a different set of 3 multiples of 10, for example, if you were to pick, say, 10, 20, and 40, for example, if you added those together, 10, 20, and 40, ten plus 20 plus 40 equals 70, but 70 isn't in the 3 times table. 70 isn't a multiple of 3. So that could be, for example, one of many, many examples you could give. So is she correct? The answer is no, she's not. But we need to give a valid example. So we could give an example like this. 10 plus 20 plus 40 equals 70. But 70 is not a multiple of 3. Essentially, if you add together any 3 multiples of 10, the first bit will always be true. You'll definitely get a multiple of 10, but the second bit is only true sometimes. It'll always be a multiple of 10, but not always a multiple of 3 as well. And so she's not always fully correct. So overall the answer is no. So you need to give an example like this one or similar and conclude with saying no, she's not right. Question 11, we've got a probability question relating to a fair spinner which has 12 equal sections. So we need to label each section A, B, C or D so that when the arrow is spun, the probability it lands on an A is 1/6. Let's just think of that for a second. If the chance of it landing on A is 1/6 and there's 12 equal sections, that must mean that 1/6 of the sections must be an A. That's got to be true if the probability of it landing on A is 1/6. But of course, how many sections are we talking about? Well, we're told there's 12 equal sections, and if you wanted to, you could count them up on the diagram. So what we need to work out here is 1/6 of 12, because there's 12 sections. So 1/6 of 12, we can just do directly by doing 12 divided by 6, or if you prefer, you can use your calculator fraction function and type in 1/6 multiplied by 12, not 13, times by 12, which gives us 2. So 2 sections need to be labelled A. Doesn't matter where you put them, as long as you put 2 sections on here and label them A. Colouring in you don't need to do, but I like a bit of colour sometimes. So yeah, 2 sections are going to be A. When it says probability it lands on B is equal to the probability it lands on C. That doesn't really help us much yet. But if we have a look at this one about D, the probability it lands on D is double the probability that it lands on A. So if it's going to land on D, let's say D is blue, if the probability of landing on D is double the probability it lands on A, what this means is that double the number of sections of A must be sections of D. The number of sections of D must be double the number of sections that A has, because the probability it lands on D is double the probability of landing on A. So how many sections of A were there? There was 2. We're going to multiply that by 2, because that's what double means. We're just going to multiply it by 2. And what we'd get here is 4. So then in any order, we can label 4 sections D. You don't need to put the D's together. You can put the D's in any order, anywhere on the diagram. It really doesn't matter. So I'm just choosing to put them next to each other so I don't forget one, for example. So 4 sections are a D. Just colouring all of this in. Now the last thing well, not the last thing it says, but we can return to what it said earlier about the sections for B and C. So far I've called in 2 sections that are A, 4 sections that are D. I am stupid today. I've called in 5 sections. Do excuse me here. So yeah, only 4 sections are D. Just going back to what it says here, the probability it lands on B is equal to the probability it lands on a C. So let's have a look how many sections we've got coloured now. We've got 2 sections for A, 4 sections for D. We've got 6 sections left. So if the chance of it landing on B is equal to the chance of it landing on a C, the remaining 6 sections must be 3 each of B and C. And so what we must have is for every time we've got a section that's B, we've got one that's C. Because the probability of it landing on B is equal to the chance of it landing on C. So 1B, 1C. 1B, 1C, and finally 1B, 1C. So in any order, what you'd need to have on the spinner is 2 A's, 4 B's, 4 D's, 2 A's, 3 B's it was, 3 C's, and 4 D's, in any order or any combination. 2 plus 3 plus 3 plus 4 is a total of 12 different sections, as you'd expect. So that's question 11 done. 2 A's, 3 B's, 3 C's, and 4 D's. Question 12. We're told that A take away B equals 5. And we need to work out the value of 2 lots of A minus B. So there is an easy way of doing this before you start panicking. So what I'm going to say first of all is we're going to use the algebra as intended. And so A minus B is the same thing as 5. And so when it says 2 A minus B, because A minus B is 5, we can replace A minus B with 5, because as I've said, A minus B and 5 are one and the same thing. To get rid of brackets, we multiply them out. And so if we expand these brackets, 2 times 5 will give us 10. If you're not sure though, just use one of these things here. 2 brackets 5 equals 10. So the value of 2 A minus B just means 2 lots of 5, which is 10. I'm going to give you another way now, which I'm going to suggest might be easier in general. A and B, we don't know what they are. It can seem quite abstract and confusing. So what you can do is just make something up. Make up a number for A and a number for B, so that when you do A take away B, the answer's 5. Here's one I've suggested. You could pick something like A equals 6 and B equals 1, because 6 take away 1 is 5. Don't think you have to think what I'm thinking. You could have done something like A could have been 8 and B could be 3, because 8 take away 3 would be 5 as well. But if we just try using A equals 6 and B equals 1, this will work as well. So 2 brackets A minus B would be 2 brackets 6 minus 1, because A is 6 and B is 1. And again, if you were to try that on your calculator, unsurprisingly, you should get 10. But I'll just show you here. See, you get 10. Part B, work out the value of 7A minus 7B. So again, you can do the algebraic way. 7a minus 7b can be factorised. There's a 7 in each group. So if I were to factorise this, I'd get 7 brackets a minus b. Because 7 times a is 7a, and 7 times minus b gives us minus 7b. But now, once it's factorised, using the algebraic method, we know that a minus b equals 5. And so this is the same as saying it's 7 lots of 5. Then if you multiply out those brackets, you'd get 35. So the answer here is 35. Now, without factorising or messing about with brackets, you could just use these suggested figures for a and b. As I said before, pick any two numbers so that whatever a is and whatever b is, a take away b gives you 5, like it should. So let's say a is 6, let's say b equals 1. In that case, 7a, which means 7 times a, 7b, which means 7 times b, would mean 7 times 6, because we're using the fact that we can say a is 6 if we like. And minus 7 lots of b is the same as saying 7 lots of 1, because we're saying b is 1. So if we try this on our calculator, 7 times 6 minus 7 times 1, again we'd get an answer of 35. So it does work. Finally, this one, work out the value of b minus a. Now this is much easier just to use these numbers. And so b minus a b is 1, a is 6. So b minus a means 1 take away 6. If we try this, we would get minus 5. So the answer to part C is minus 5. So if you've got a problem with algebra and you don't know where to begin, you can always try to just pick any two numbers at work and take it from there. All we need to have is that a take away b equals 5. So you could have a equals 20 and b equals 15. You could have anything as long as a take away b equals 5. Question 13. We've got a cube that has a length of 0.9 meters. We're asked here to work out the total surface area of the cube, but we need our answer in square centimeters. So, we want the answer in square centimeters, but here the dimensions are in meters. So the best thing to do first of all will be to change meters into centimeters. So what we need to do first of all is remember how many centimeters makes a meter. And the answer to that one is there's 100 centimeters in a meter. So we've got a relationship between meters and centimeters. One of the numbers is 1, the other number isn't a 1. If you've got a relationship or a ratio in this form, where one number is 1, the other number isn't 1, we change from one to the other by either multiplying or dividing by the number that isn't 1. So that is, in this case, multiplying or dividing by 100. So if I'm changing from meters to centimeters, I'm going from a small number to a bigger number. So I'm going to be multiplying. Going the other way around, from 100 down to 1, I'm going from a big number to a small number. It's going to be dividing by 100. But what we're interested here is converting to square centimeters, because we want our answer in square centimeters. So what we could do is multiply this by 100. And so 0.9 meters, if I times that by 100, I'd get 90 centimeters. So when it says the cube has edge length 0.9 meters, That's just another way of saying it's got edge length of 90 centimetres. And so what we can do now is just think of the cube in terms of centimetres entirely. So that's 90 centimetres. The thing with a cube, all the faces are a square, and the special thing with a square is all the sides are the same length. So with a cube, all the sides of the cube are the same length too. So we want to work out the total surface area of the cube. So what we can do is work out the area of one surface. The surfaces of a cube are all going to be squares. And so if I just have a look at this surface over here on the side, the purple surface, we can set about working out the area of this surface. So that surface is a square. How do we work out the area of a square? Well, the area of a square is the length multiplied by the width, but because a square, the length is the same as the width, that's just 90, multiplied by 90. So 90 multiplied by 90 would give us an answer of 8,100. Centimeters squared. So each face of the cube has an area of 8,100 cm squares. But we need to work out the total surface area of the cube. A cube doesn't have just one surface, a cube has 6 faces. So the total surface area for all 6 faces, each face of a cube will be the same size square. That'll be 6 multiplied by 8,100, because a cube has 6 faces, in the same way a dice has 6 sides. So finally, if we do 6 multiplied by 8,100, we should get our final answer. So 8,100, multiply that figure by 6, we'd get 48,600. Centimeters cubed. And that's our final answer. Question 14. We've got £1,700, which is invested for 3 years at 4% per year, simple interest. Simple interest just needs mentioning. It's different to compound interest. Compound interest is what you have in real life. For compound interest, the interest changes from each year and each year. Normally the interest gets slightly bigger each time, but with simple interest, the interest is fixed. So for simple interest, here's what we do. What we do is work out the interest for 1 year. Secondly, multiply that value by how many years the money is invested for. So that's just worth recapping. It's easier applying it with the maths than writing it down. It sounds more complicated than what it is. So first of all we need to do is work out the interest for 1 year. So for 1 year, the interest is going to be 4%. So 4% means 4 out of 100. By definition, percent means out of 100. And so 4% of the original amount we can work this out. So 4% of 1,700 comes to £68. So for 1 year, the interest is £68. Step 2, I said multiply that value by how many years the money is going to be invested for. So this money here is going to be invested for 3 years. So for 3 years, the interest will be the £68 interest for 1 year multiplied by 3, because again it's being invested for 3 years, not just 1 year. So finally we do 68 multiplied by 3 and we get our final answer of £204 interest in total. So that's what we write on our answer line. And question 14 is done. Question 15, we've got a scale diagram. And it says, here is a map showing 2 towns P and Q. And we're given a scale, which is very important. The scale we're given says that each centimetre on the map represents 50 kilometres in real life. Okay, so again what we can do is just write this down. So 1 centimetre on the map represents 50 kilometres in real life. Now this is a conversion from the map to real life, and this is a ratio conversion in the form where one number is a 1 but the other number isn't a 1. So if ever you have a conversion in this form, you can change from one to the other by multiplying or dividing by the number that isn't 1. In this case, the number that isn't 1 is 50. So if we're changing from centimetres on the map to kilometres in real life, we're going from a smallish number to a bigger number. So we'd multiply by 50. Therefore, going the opposite way round, we'd be doing the opposite thing and dividing by 50 instead. So this is the map. This is reality. So to change from our distance in centimetres on the map to the distance in kilometres in reality, we just multiply by 50. What we're going to have to do for this one is actually measure on the map the distance from P to Q. So we need to measure this line here. And the way to measure is with a ruler. So we need to get our ruler to hand and measure it from P. And so we put our 0 at P, then make sure it's in line with Q. And what you should be able to see on your diagram is that the line PQ is 7 centimetres. Now if yours is slightly different, say 6.8 or 7.2, it could well be just a photocopying difference. Each photocopy is slightly different to all the others, so get your teacher to come over and check it for you if you're not sure. But you should have something in the region of 7 centimetres. If it's wildly out, if it's much different to 7, either you're reading it wrongly or your diagram's been resized in some major way. But anyway, as I say, you should find that the distance from P to Q is 7 centimetres. And so what we do is we take 7 centimetres, this distance here, and multiply it by 50. According to what we set up here, to change from the map distance to distance in reality, we're going to multiply by 50. And so we measured 7 centimetres, and the conversion factor, like we mentioned before, is 50. And so what we're going to do is 7 centimetres multiplied by 50, and that's going to give us somewhere in the region of 350 kilometres. Your answer should be very similar to this, unless, as I say, your map's been significantly resized, but ask your teacher if you're not sure. Now part B, we're told that town R is 200 kilometres due south of town P. Due south means directly below. Remember, with a compass, I'll just draw a very quick compass here. North, north is the line going up, south is down, east points to the right, west points to the left. So as I was taught in school, never eat shredded wheat. So due south means below. So if I just return for a second to the scale we had in part A, 1 centimetre, ... 50 kilometres, we can use this to work out where to place it on the map. So here we're saying town R is 200 kilometres due south of town P. If 1 centimetre is 50 kilometres, how many centimetres would be 200 kilometres? Another way of putting this is, what would I need to multiply 50 by to get 200? How many 50s fit into 200, you could think? Well, we can work this out directly on a calculator by doing 200 divided by 50. You may have spotted it's 4. So it's 4 lots of 50. So we need to do the same to this part of the ratio as well to keep it in balance. So 1 multiplied by 4 means that on our map we're going to be drawing 4 centimetres. And so 200 kilometres in real life links to 4 centimetres on our map. So town P is going to be 4 centimetres directly below town P. So again, we need to get our ruler to hand. Put it on P and measure 4 centimetres directly below P. So start at 0 and measure 4 centimetres directly below. So that's 1 centimetre, 2, 3, 4. And so town R is going to be here. So we can mark that on with an R on the map. 4 centimetres directly below P. And that's question 15 completed. Question 16, we're talking about a train. So let's just think about what it's asking us. We've got a train with 1 first class carriage and 6 standard carriage. The first class carriage has 64 seats, 3/8 are being used. So I'm just going to think about this for a second. What we're going to do is section it all off. We've also got some information about standard carriages, where 7/13 in each carriage are being used. And it's saying more than half the seats on the train being used, you must show you're working. So let's just think of it step by step. And so first thing that's been mentioned is the first class carriages. So there's 1 first class carriage and it's got 64 seats. So for first class, If there's only one carriage, it's got 64 seats. The total number of seats is 64. So 64 first class seats. Now 3/8 are being used, so 3/8 of 64 are being used, so we can calculate that fraction of the amount directly. So we can either just do 64 divided by 8 multiplied by 3, or we can use a fraction button on the calculator. 3/8 of 64. So 24 are being used. So in the first class, 24 out of the 64 are being used. Now we can have a look at the standard carriages. Each standard carriage has got 78 seats. So we're told that there's 6 standard carriages. So if there's 6 carriages, and each one's got 78 seats, the total seats here will be 6 carriages multiplied by the 78 seats per carriage. So 6 multiplied by 78 is 468. So you've got 468 standard seats and 64 normal, sorry, not 64 normal seats, 64 first class ones as well. We'll come back to that in a second. Just thinking about these standard seats, it says 7/13 in each carriage are being used. So of these 468 standard carriage seats, 7/13 of those are being used. So it's that fraction of the 468 which we need to work out. So again, what we can do is type in the fraction and then put it multiplied by the total amount we're talking about, which is 252. And so what we've got here is 24 first class seats being used and 252 standard seats being used. So total seats being used is 24 plus 252, what I've highlighted here and underlined in red. So 24 plus 252 you should get a total of 276. Total seats on the train well, 64 first class seats and a total of 468 standard seats. So the total seats on the train is for 64 total first class seats plus for 468 standard carriage seats. So if you add these together, 64 plus 468 we get 532. So there's 532 seats altogether, of which 276 are being used. And so there's 2 ways now we can compare these two. We could think about what's half of 532 first of all. and compare the total seats being used to what half of 532 would be. So half of 532 is just 532 divided by 2, which is 266. So that would be half of the seats being used if there are 266 seats being used, but actually 276 seats are being used. So 276 is more than half because 276 is higher than 266. Therefore, the actual end question, are more than half the seats on the train being used? The answer is yes. Another way we could have shown that would be to have done this total seats used as a fraction of the total seats. So 276 seats are used as a fraction of 532, press equals. Now we can compare that to a decimal, which is 0.51, multiplied by 100 to change it to a percent. Oops. That's roughly 52%. And so the percentage of seats being used is roughly 52%, whereas half would be exactly 50. 51.8 or 51.9, as it is, to one decimal place, is higher than 50%. Therefore, yes, once again, we could say that more than half the seats are being used. Not much more than half, but still it's more than half. Question 17, we need to circle the equation that has the solution x equals 6. Solution just means the answer. So which one of these fits x equals 6? What we can do here, because we've got a calculator, we can just put in that x equals 6 into every single equation and compare. So the first one, x minus 3 would mean 6 take away 3. 6 take away 3 equals 3. And x over 2 would mean 6 over 2, because x, yet again, is 6. So 6 over 2 would equal 3. And so yeah, this side is equal to 3, and that side is equal to 3. So you know it's got to be this one here. If you tried all the others, they wouldn't work. I'm not going to do all the others because we know what the answer is now. But for example, x over 6 equals 0. Well, if we put x equal to 6, 6 over 6 equals 1, not 0. So it's not going to be that one. You could try them all in the same way. None of them would work apart from the first one. So we circle this first equation here. That's our final answer for question 17. Question 18, another multiple choice job. We've got 4 different inequalities. And what it says here in the description for the question is that x is greater than 5 and less than or equal to 9. And so x is between these two numbers. So x is greater than 5. So it means that if there were a hungry crocodile, would the crocodile choose to eat the 5? Or would the crocodile choose to eat the x? The crocodile's open mouth will always face the bigger thing. And so the open mouth of the inequality sign will face the x, because we're told in the question that x is greater than 5. So greater than means the crocodile would rather eat the x, because x is bigger than 5. It's a bigger meal. And we all know crocodiles are very, very greedy. It also says, after it says x is greater than 5, it's less than or equal to 9. And so x could be less than 9. And so if a crocodile were to go for x or for 9, it's saying here that because x is definitely not bigger than 9, the safest bet would be to go for the 9. Because 9 might be bigger than the x, but it also says less than or equal to 9. Now, if an inequality symbol is less than or more than, and it says equal as well, we have an extra bottom line to it, like this. So that means x is less than 9, or it could be equal to 9. The way I used to remember it is if you remove the top bit of the inequality, it looks sort of like a slanted equal sign. So that's the inequality that's been described. Less than or equal to 9 is that symbol there. So which one of these below looks like this? And the answer is it's got to be the last one. So we circle this one here. Question 19, we've got some data from a large sample survey of audience at a concert. We need to make 3 comparisons of males and females at the concert. And it says here to use the headings given. So be careful to read the question carefully. Use the headings given. The headings are these things here I'm going to circle. These are the headings. And so here it's saying proportion. I can't see proportion anywhere. Average. I don't see average anywhere. Spread of ages. Again, I don't see spread. The trick here is that each one of these 3 things is going to relate to each one of these 3 headings. The examiner's testing if you can relate proportion, or if you can describe proportion in terms of these things here. Proportion links to percentage. Average can relate to the mean, because mean is a type of average. Mean is the usual average people use, in fact. If you just say average, rather than thinking the mean, mode, or median, people will assume if you just say average, it's the mean. And spread, range measures the spread of data. The smaller the range, the smaller the spread of data. Range measures spread and also consistency. So proportion of the audience means we're commenting on the percentage of the audience. So here, a bigger proportion of females were in the audience than males. Because again, remember, we need to make headings, used to make use of the headings given. So we can't say proportion, we need to say percentage. So we can say something along the lines of a bigger percentage of females were in the audience than males. Average age. Average here is going to relate to the mean. So the mean age of males was less than the mean age of the females in the audience. And finally, the spread. The smaller the spread, the smaller the range. And so whichever has a smaller spread has a smaller range. And so because the males had the smallest range, they had the smallest spread of ages. So for male audience members, had a smaller spread of ages than the females. So you don't need to put exactly what I've put, but words similar to what I've put there will get you the marks. So a bigger percentage of audience members were females than males. The mean age of the males was less than the mean age of the females, or you could say the mean age of the females was greater than the mean age for the males. And then finally, the male audience members had a smaller, you see, I've almost made a mistake. I don't put spread, I need to put range. Right, I've noticed that in time. Because I've noticed it in time, I'm leaving that mistake in. I'm leaving mistakes in for two reasons. One, to show you that I'm definitely human, and also to show you how easy it is to make a mistake, and anyone can make a mistake. So, smaller range of ages than females. And so that now is okay. Proportion, use percentage as the heading. Average, we need to use the mean in the description. And for spread, we need to use the word range. And so that's finally question 19 done. Question 20, we have to look at this Venn diagram. So we're talking about a tennis tournament for this question. And we've been given a Venn diagram to help us. So it says 98 players took part in the singles only, 34 players took part in the doubles only, and we're told that twice as many players took part in the singles as took part in the doubles. So singles only is here, doubles only is this section of the Venn diagram. And when it says how many players took part in both the singles and the doubles, this bit in the middle represents singles and doubles because it overlaps with the singles part and the doubles. And so people in this overlap are both part of the singles circle and the circle that represents the doubles. So this bit here is singles and doubles. So I'm just going to take the time to just colour code some of this in here now. So for singles only, it's just this fraction of the singles circle. It doesn't include everything. It's just the part of the circle that only is for singles. So it's a bit that doesn't touch the doubles circle at all. And so in this bit of the circle belongs those 98 players. At the other side, the other circle, we're told that 34 players took part in the doubles only. So the doubles only is over here at this side. So I'm just going to colour this in. Apologies, I know watching me colour in isn't going to be riveting, but I'm hoping at least it'll make it clear in terms of what I'm talking about. If I just colour code information according to what you see in front of you, so you can link the information to the diagram. That's my excuse. The truth is I just love to colour in because I was always bad at it as a child and it's left me as a very, very bitter adult. I'm joking. So this is, the green bit is for the people playing doubles only. Of which there's 34 players. But the question's asking us, how many players took part in both the singles and the doubles? The singles and the doubles, as I've mentioned earlier, is going to be represented by this overlapping part of the circle. Now we're not told how many of them are playing both singles and doubles, not just one or the other. And so what we need to do, or what I'd suggest we do, is to think of a letter for this bit we're trying to work out. And what mathematicians tend to do is they just call everything and everything an X. So if in doubt, call an X. And so we want to work out how many players took part in both the singles and the doubles. And so if we have a look at this sentence over here, it says twice as many players took part in singles as took part in the doubles. And so people that took part in singles, all the people in this left circle, including the overlap, all what I'm circling around here is people taking part in the singles. So people taking part in singles is a total of 98 plus X. And people taking part in the doubles is people on the right hand side circle, including the bit where the right hand side circle overlaps with the other circle. So the doubles playing people are the people that just play doubles only, plus those people that dabble in both doubles and singles. So that's going to be X plus 34. And so just reading this again, it says twice as many players took part in the singles as took part in the doubles. And so this number of people here is going to be double this number of people over here. And so this figure here is double. Double means twice as big. This is twice as big as all of this here. It's a bit to get your head round. But what we need to do now is solve this equation. So the first thing I'd suggest we do is expand the brackets to get rid of them. So we need to do 2 multiplied by x, which is 2x, and 2 multiplied by 34, which is 68. Now we've got unknowns on each side of the equation. What we need to do is get the x's to the same side. So what we can do is move the smallest number of x's to join the other group of x's. Now this x over here is a positive x, it's plus x. When it swaps side, it swaps sign. Opposite of plus is minus. And so after this x has moved, on the left we'll just have 98. On the other side we'll have 2x minus the x we've just moved, 2x minus 1x, leaves us of only 1x, plus of course 68. So we've got the x's on one side. What we want to do on the other side of the equation is have the units. So we're working towards having the x on its own. That plus 68 can therefore just go away to the other side. But if this swaps sides, it will swap sign. Opposite of plus will be minus. And so x will be 98 take away 68, which is 30. So x equals 30. And remember, we said x was going to represent how many players took part in both the singles and the doubles. And so that number of people is x, which is 30. So that's our final answer. Number who played both singles and doubles is 30. Probably the hardest question on the paper, or definitely one of them, in my opinion, in terms of getting your head around it. Question 21. We're told a distance by road from Newport to London is 140 miles. And Tom's travelling by coach from Newport to London, and the coach leaves Newport at 1:30 p.m. So we're told a distance. We mentions a speed in part A, but here assumes the coach will travel at the average speed of 50 miles per hour. Uses assumption to work out the travel time in London. So it relates to speed, distance and time this question, and there is a formula for relating speed, distance and time, which is this question here. So what we're wanting to work out here is the arrival time in London. So I think what I'm going to work out is the time. So the way we use this triangle is we cover up the thing we want to work out. So cover up time, and whatever's left in the configuration it's written in tells us what to do. So this here, we've got D on top and S on the bottom. Now in maths, what has a top and a bottom, it's a fraction, because D is at the top of the triangle and S is at the bottom. So what we need to do is find the information we need. So D represents the distance travelled, and luckily we're told this in the first part of the question. The distance by road from Newport to London is 140 miles, and so we can fill that in. The distance is 140 miles, and the speed is 50 miles per hour. So the speed units mentions hours, and so if we're putting a unit of speed which has hours in it, if we put hours in, hours will come out. And so the unit of time we're going to find here will be in hours. So 140 divided by 50 will give us the time taken in hours. So 140 divided by 50 equals 2.8 hours. Now this is where so often mistakes are made. 2.8 hours. People tend to then guess and think, oh, that must mean 2 hours 8 minutes. It doesn't, because decimal systems are base 10, but there's 60 minutes in an hour, so it's a completely different system. So what I'm going to do is show you two different ways of working out how long this takes in hours and minutes. What I would suggest you do is just remind yourselves of how long 1 hour is in minutes. And obviously I'm sure you know that 1 hour is the same as 60 minutes. The good thing about this conversion factor is it's in the form of one number is 1, the other number is not 1. This is technically called a ratio in the form 1 to n. The good thing about this one is, if you've got a number which is 1 and the other one that isn't 1, we can convert from one to the other by simply multiplying or dividing by the number that isn't the 1. So in this case, the number that isn't 1 is 60. So we're either going to be multiplying or dividing by 60. If we're changing from hours to minutes, the minute number, 60, is bigger than the hour number, which is only 1. So going this way round, from hours to minutes, we'll be multiplying by 60. So going the other way around, if we're going the opposite way, we'd be doing the opposite thing. The opposite of multiplying by 60 would be dividing by 60. So that's how you can change from hours to minutes. So using this fact, we can convert this time into minutes by simply multiplying the whole thing by 60. So if we multiply 2.8 by 60, that'll tell us the time in minutes. 2.8 times 60 is 168 minutes. Then from that we can work out how much this is in hours and minutes. So there's 60 minutes in an hour, so 2 hours would be 120 minutes. So if we take away 2 hours worth, if we take away 120 minutes, we've got 48 minutes left. And so that's 2 hours, 48 minutes. So the coach leaves Newport at 1:30, so it leaves at 1:30. If we think about what time it would be in 2 hours time, because 168 minutes is 2 hours and something, in 2 hours time the time would be 3:30. I'm going to give you another way of doing this in a second, so just bear with me. So in 2 hours, the time would be 3:30. Then another 48 minutes time. 3:30. Well, how long would it be to get to 4 o'clock? From 3:30 till 4 would be an extra 30 minutes. So that takes us to 4 o'clock. So 2 hours we've used, but what we haven't used all of yet is the minutes. So we've got 48 minutes as well as the 2 hours. So this is using 30 minutes to get to 4 o'clock. 48 take away 30 is still another 18 minutes still to travel. So if we add on a further and final 18 minutes, that will take us to 4:18 p.m. And so the arrival time in London is 4:18 p.m. I'm now going to show you a much easier way, but only if you're comfortable using a calculator. So if I just return to the time, which is 2.8 hours, your calculator has the ability to change to time mode for you. Now this will take practice, so I'm not recommending you do it unless you're really going to be working hard to understand this calculator function. But just in case you are one of those people, I'm going to mention it. If what I'm going to say afterwards, after this confuses you or you don't like it, by all means just refer to this previous method here. But if we type in 2.8 and press equals, this button here, which looks like apostrophes, if we just press this button here, it converts it for us into hours, minutes and seconds. And so 2.8 hours is 2 hours, 48 minutes and no seconds, which is what we worked out before, but it was much harder doing that on your own. So now what we can do, because the time's going to be 2 hours and 48 minutes of travel, we can add this on to 1 hour 30. So I'm going to show you how you can type in 1 hour 30 on your calculator. So do plus, because we're adding it on. Press 1. And then this one here, that symbol means hours. The next time we press it will be minutes. So 1:30 means 1 hour 30 minutes past 12 o'clock. If you pressed it again, you don't have to, but if you press some digits again and then pressed this button again, it will go into seconds. So hours, minutes and seconds. So I'll just show you, it's 1 hour 30 exactly, 1:30. So that's 00 seconds, just to show how it works. So hours, minutes, seconds. So this answer added to 1 hour 30 would be 4.3, and again that's in decimal mode, so press this to change it to time mode and we get 4 hours 18 minutes 0 seconds. So it's exactly 4:18 p.m. That will take practice to master, but if you were to master it, it might make these calculations much easier for you, so it's worth bearing in mind. Part B, you'll be pleased to know, is much easier if you just think about it. Part B, it says, in fact the coach has a lower average speed. How does this affect the arrival time? If you just think about it, use common sense. If a coach travels slower than the average speed, it'd take longer to get to where it's going. So how would this affect the arrival time? The arrival time would be later. If it's travelling slower, you're going to get there later, aren't you? The arrival time would be later, or words to that effect. And that's question 21 done. Question 22, you can already see I've put method 1. So yeah, it's one of those questions where there's multiple different ways of getting to the correct answer. First of all, we're told that ABCD is a parallelogram and that AB equals BP. And so this side here is the same as that side there. So what it means is ABP, that triangle, is isosceles. So I can just make a note of that here. That's an isosceles triangle. We can solve this problem by either using angle facts of a parallelogram, if you can remember them. I'll tell you what they are in a second. Or if you can't remember much about a parallelogram, I'm going to show you how you can tackle it using pretty much purely just angle facts without using the parallelogram facts. So what you need to remember for this method, this first method, is about corresponding angles. So if I were to just do a straight line from B to P to C, and a line here and a line there, I'm hoping you'll see this looks like an F laid down on its side. So why am I mentioning about Fs? Well, it means the corners of the F, the armpits of the F, if you don't mind being a bit gross, are equal in the corresponding angles. So we can say these two are corresponding angles because these two sides, CD and BA, are both parallel because it's a parallelogram. And so the angle at C will be the same as the angle there at B because corresponding angles are equal. So the angle outside B, it's not actually inside the parallelogram. So the angle outside B, if you like, is the same as this whole angle here. So it's made up of 1x and 3x, so that's the same as 4x's altogether. Now F angles are called corresponding angles. So if you can remember it, put it down. If you can't, carry on anyway, because luckily for you guys, this question isn't stating about using the angle facts. But it's always worth writing them down if you can remember them. Corresponding angles are equal. That's how we know that much. So, just return to this triangle for a second. I did say it was isosceles. An isosceles triangle means two sides are the same, which we're told here, and two of the base angles are also identical. The base angles just means the two angles which are where the two equal sides don't meet. Where the two equal sides meet, that's the odd angle out. Where they don't meet, here and here, is where the angles are the same. So because this one's 51, angle BAP will also be 51. So I'm just going to colour this one in here. So this angle is the same as this angle down here. So we can write this down as saying BAP equals angle APB, which is 51 degrees. And we can use that angle fact because we know it's an isosceles triangle. So once we know that, we can then work out the angle at B, ABP. So ABP, remember angles in a triangle add up to 180 degrees. So the angle ABP will be 180, take away these two that are 51. So 180 take away 51, take away 51. equals 78 degrees. So we can label this in. So if this one's 78 degrees, what that will tell us is that this one here, the angle at B, will be 180 take away 78 degrees, because these two angles here lie on a straight line, and angles on a straight line always add up to 180 degrees when they're touching. So if this one's 78, this one here will be 102 degrees. So the angle outside B, which I mentioned before, which equals 4x, is 102 degrees. And because that's the same as 4x, what we can say here is that that one is the same as 4x. So the angle outside B, which is 102, is the same as 4x due to this initial thing we said at the very beginning of the question. We want to work out what x is on its own. So this 4 is in the way, really. So what we could do is move this 4 to the other side of the equation to get rid of it. So we've got x on its own. That 4 is multiplying the x. If we swap the side, we swap the sign. Opposite of multiplying is dividing. And so that tells us that x is 102 divided by 4, which is 25.5. So using this method, x is 25.5 degrees. If you hate that method, panic not, I'm going to mention a different method now, which I've very unimaginatively labelled method 2. So using method 2, I'm just going to shortcut a few different things here based on what we've already learnt from method 1. So this is an isosceles triangle. Which means the base angles are the same, which in plain English means if this one's 51, the other one will also be 51 degrees. Now what we can do is work out the angle at B. So first of all we can say BAP is 51 degrees, because it being an isosceles triangle. Therefore, angle ABP we can work out because angles inside a triangle add up to 180. So angle ABP will be 180 take over two angles we now know. So take away 51, take away 51 gives us 78 degrees. Angles in a triangle add to 180. That's the angle fact we've used there. Now I did say method 1 was not using any parallelogram facts. We're going to use some here for the second method. So first of all, we said that ABP is 78 degrees. So I'm just going to add this into what we know. So this one here, we've just calculated will be 78 degrees. Now what you might not have been taught explicitly, or if you have and you may have forgotten it, is with parallelograms, one of the properties of parallelograms is the opposite corners of them are equal. And so if this one's 78, the angle up here will also be 78 degrees as well. So if we fill this bit in, that'll help us. Now if we have a look at this triangle at the top, ACD, we know 78, we know this one's 3x. What we could do if working out though is this angle here. Now what we could do is apply an angle fact. If we do a straight line from P to C, and then a straight line going up here. I'm no good at doing straight lines, as you can probably tell. That's okay. And then from A to here, hopefully you can see this is a sort of back to front Z angle. So if this one's X, the other corner for Z is also equal. So this angle here at the top will also be X, because alternate angles are equal. So we can put that down if you'd like. Angle CAD, the angle at A, is the same as this angle here, which is PCA, equals X. Now Z angles aren't sadly called Z angles, they're called alternate angles. So I'm just going to mention that alternate angles are equal. So now we know that, what we can do is just ignore the rest and just focus on this top triangle. So I'm just going to rub off everything else so we can just focus without any distractions from the other bits of the question. We can just look at the top triangle now. There we go. So just looking at this triangle, you should know by now what the angles in a triangle add up to. And what that is 180 degrees. And so these three angles here will add up to 180. And from that we can generate an equation relating to x. And so using this one here, x plus 3x plus 78 will add up to 180, because angles inside a triangle do always add up to 180 degrees. So just highlighting these angles as they are in the triangle so you can see where the numbers are coming from. Now this equation can be simplified. I'm just going to move over here so I've got more space to write. X plus 3x is a total of 4x's plus 78 equals 180. We want to have the x's on their own, so what we could do is get rid of this plus 78. If we swap the side, we swap the sign. Opposite of plus is minus. And so what we get here is 4x will equal 180 take away 78, which gives us 102. And to get to just 1x, we can get rid of this 4, which is multiplying the x, by yet again swapping the side and swapping the sign. Opposite of multiplying by 4 is dividing by 4. And so x will be 102 divided by 4, which, as we saw from method 1, is 25.5 degrees. So using method 2, again we get 25.5. Now a third method, you're probably thinking, why is he doing so many different methods for just one question? Well, the reason is these angle questions I've found in my experience can be confusing in terms of people not knowing where to start. So I'm just trying to show you all that if you're in doubt, there might be multiple different approaches you can come to. So if you can't find it one way, maybe flick through the paper and return to it with a fresh set of eyes later on, because chances are there's more than one way of getting the correct answer. Anyway, method 3. We're going to use another fact now when it comes to parallelograms. So what we're going to say here is, first of all, we need to spot a angle fact. So if we imagine a line running along BP, and then from P running up to A, and then from A going towards D, that makes a back to front Z angle. So if this one here is 51, this angle here will also be 51. Because Z angles, which are called alternate angles, are equal. So if you wanted to, you could write that down to impress the examiner. So angle PAD is equal to the angle APB, which is 51 degrees. And the reason is alternate angles are equal. Now we're going to have a look at this triangle. Two sides of a triangle are equal, AB equals BP, and so yet again we can just label this as an isosceles triangle. Isosceles triangle means two sides are the same, but more than that, two angles are the same. So because this one's 51 here, this other angle here will also be 51. Because this one's 51, angle BAP is also going to be 51 degrees too. So the reason we can do that is because we know it's an isosceles triangle, and the base angles are always the same. So looking at this one here, the corner of A, BAD, the whole corner, BAD. I'm going to just highlight the whole corner, and what I mean by that is this whole big angle here, all the way across. So I'm just going to try and colour it in so it's a bit clearer what I mean by BAD. I mean the entire corner. So angle BAD, in a way it comprises these two smaller ones. BAD is the sum of 51 plus 51, which is 102 degrees. Now we're going to use another fact about angles inside a parallelogram. And what this is that the opposite angles, the opposite corners of a parallelogram are always of equal size. And so the opposite corner of this parallelogram is this corner here. So this corner here, which is x plus 3x, which is a total of 4 x's, is equal to this one over here. So we can write this one down. X plus 3x is 4x, and that equals 102. And the reason we know that, we can write down, is basically the opposite corners of a parallelogram are of equal size. That's always true for all parallelograms, by the way. So we can always use that angle fact if and when it rears its ugly head. Anyway, we don't want to have 4x's, we want just 1x, don't we? So how can I get rid of that 4? What I can do is I can chuck it to the other side, but if we swap the side, we swap the sign. Opposite of multiplying by 4 is dividing by 4. So x equals 102 divided by 4, which, doing it this way, again you'd find x is 25.5 degrees. And so I really have lingered on question 22 just to show you that there are multiple methods for arriving at the correct answer. 3 different methods I could think of, there may be more. But anyway, that's question 22 finally done. Question 23. We have to show that 268 can be written as the sum of a power of 3 and a square number. Sum just means added together. So it's worth just writing down just to remind us what sum actually means. So a power of 3, we can think about powers of 3 on one hand, and it was also mentioning about square numbers as well. So we can do a list of powers of 3 and square numbers. Now powers of 3, what it means is 3 to the power of whatever. So powers of 3, the first power of 3 is 3 to the power 1. Now 3 to the power 1, anything to the power 1 is just the number itself. 3 to the power 1 is 3. Let's try 3 squared. 3 squared is 9. You can try it on your calculator if you want to. So 3, 9. Let's try 3 to the power 3. 3 cubed this is called. Now again, luckily your calculator does have a cubed button on it. If you press the number you want to cube, or raise to the power 3, there's a button here for it. So 3 cubed means 3 times 3 times 3, which is 27. Let's keep going, because 268 is quite a big number. So 4 cubed. Sorry, it's a bit late and I'm a bit tired. I mean 3 cubed. No, I don't. I mean 3 to the power 4. Wake up, Sean. 3 to the power 1, 2, 3, and 4. So 3 to the power 4, I'll show you how to use a power key on your calculator. So press 3, and this button here, then type in the power we need, which in this case is a 4. And that's going to be 81. And 3 to the power 5 equals 243. Now if we did 3 to the power 6, that'd be way too big. I'll show you though just to make sure. But you can see it. 3 to the power 6 is 729. We don't want to go beyond 268. And so these first 5 powers of 3, somewhere in these is going to be the key to our answer. So these are the powers of 3. Let's now think about the square numbers. And what we're hoping will happen is that the square numbers, when I add it to the power of 3 above, will come up to 268 at some point. So the first square number is 1 squared, which is 1. The next square number is 2 squared, which is 4. You should really know square numbers quite well up to 10 squared, but if not, check on your calculator if you're not sure. 3 squared means 3 times 3, which is 9. 4 squared means 4 times 4, which is 16. 5 squared means 5 times 5, which is 25. 6 squared equals 36. 7 squared is 49, and they just keep going on forever and ever. So you might be thinking, God, you could be here all day. Well, technically, yes, you could, but the examiner, although they might be cruel, or seem cruel, they're not going to be absolutely rotten. So let's be thinking maybe it's not going to take all day. Let's have a look what we've got so far. 268. Well, I've not gone very high with my square numbers, so let's see if 243 matches to any of them. 268, take away 243. Is that a square number? It is, you know. 25 is 5 squared. And so we've got it already. So 5 squared is 25. And so 268 it equals 3 to the power 5 plus 5 squared. So the power of 3 is 3 to the power 5, and the power of, sorry, the square number is 5 squared. So we've proved it using this list. 243 plus 25. So if we pick these two numbers here, group them and add them together, that does come to 268, which is what we wanted to prove in the first place. And so we've proved it there quite clearly. 3 to the power 5 plus 5 squared equals 268. Question 24, it says y is inversely proportional to x and k is a constant. And so I'm just going to mention what direct proportion means, because you can't mention indirect or inverse proportion without mentioning direct proportion. If y is proportional to x in direct proportion, you can say y equals a number, a constant number, multiplied by x. So y would equal a number multiplied by x. Now in algebra you don't need a multiplication sign, so you could just say y equals kx. Inverse proportion used to be called indirect sometimes. Inversely proportional is the opposite idea. So if direct proportion means, if y and x are directly proportional, then it means this. If y and x are inversely proportional, it means instead of k times x, y equals k divided by x, which we can write as k on top and x on the bottom. Just remembering that any fraction works the same way as division. Top number divided by the bottom. K divided by x. In this case, we wanting to find the equation which relates to inverse proportion. So which equation is like this one? It's actually the first option. And so we need to circle the first one. The second one, it's worth noting, that's direct proportion. So the one we're circling is the first one, y equals k over x. Question 25, we've got a formula for pressure, force and area. Now, kindly we've been told the formula here, so pressure is force over area. Just a shorthand way of doing it here. So what I've done is I've just called pressure P, force F, and the area through which the force is acting I've called A. And so what we're wanting to work out, it says here, is the force when the pressure is 24 newtons per square metre, that's 24 pascals, and the area is 3 square metres. And so I've just rewrote this equation as so. Now because we want to work out the force, we want the force on its own. So we don't want the area next to the force. What we will need is force on its own. So that area can move to the other side. So if that area swaps side, it swaps from doing what it is now to the opposite sign. That's force divided by area. Opposite of dividing is multiplying. And so what that's saying is that the force is actually the pressure multiplied by the area. So we can use that fact now. So we know what the area is, and we're told what the pressure is. So in our case, the force is going to be for pressure, 24, multiplied by the area, which is 3. And so if we were to just process on the calculator 24 multiplied by 3, what you'd find is that the force will be 72 newtons. So the one we need to circle is this one here, 72 newtons. Question 26. We're told that 42 men and 38 women visit a restaurant. So before we even carry on reading the question, it's worth just noting down how many people there must be in total. So if you've got 42 men and 38 women, we can work out the total number of people. So that'll be 42 added to 38. So if we just get our calculators and just do 42 plus 38, or even without a calculator if you're confident, there'll be 80 people in total. So 80 is our start number. So now we can read on and piece together the other bits of the question. So 80 people have a voucher, hence the 80 here. Then says 44 of these people have a voucher. And so voucher, yes, is 44. So we can put 44 there because we're told that 44 of these people have a voucher. Now, with frequency trees, each time they branch, the total of the branches will always have to add up to where it branched from. And so this one here, plus the branch for no, needs to add up to 40. And so we can calculate this one over here by doing 80 take away 44. So that should be the other 36. But again, just check the calculator, make sure you don't make any silly errors. That goes for me as well half the time. So 80 take away 44 is 36. So if 44 people did have a voucher, we can work out from that that the other 36 people didn't. That one's 36. It now says that 3 times as many men as women do not have a voucher. So this is about the people without a voucher. So if the ratio of men to women that don't have a voucher is 3 to 1. I'm not surprised that men are more disorganised than women. 3 times more men have come voucherless than women. So there's 36 people in total that didn't have a voucher. And so what we're saying is these 36 voucherless people are split into men and women in the ratio 3 to 1. So for every 3 men we have without a voucher, there's also 1 woman without a voucher. So in total, 36 has been split into 1, 2, 3, 4 different lots of people. And so we can work out how many people's in each group, if you like, by doing 36 divided by 4. We get the 4 from 3 plus 1, which is 9. And so the number of voucherless men is 3 times 9, 9 plus 9 plus 9, which is 27. And there's 1 lot of voucherless women, which is just 9, because 1 times 9 is just 9. So completing the frequency tree. So we've got here that there's 42 men in total. 27 men don't have a voucher. So the number of men that do have a voucher, this one over here, will be 42, take away 27. 42 men in total, 27 don't have a voucher. That tells that the other 15 must. In the same way with the women, there's 38 women in total. If 9 women don't have a voucher, we can calculate the number of women that do. Whoops, wrong one. Number of women that do have a voucher will be 38, take away 9, which your calculator should tell you is 29. And as a double check to make sure our figures make sense, total these up. 15 plus 29 gives us 44, as it should. 27 plus 9 is 36. And as I said from the very beginning, 44 plus 36 is the 80 we began with all along. So that's question 26A done. Now part B is about this voucher again. So it says, a voucher takes 15% off the bill. After using the voucher, the bill for a meal is £27.20. It says, how much was the bill before using the voucher? So this is a reverse percentage question, because a percentage change has already been applied. So what we're told here is the voucher's taken 15% off the bill. Before anything happens to a number, you always start with 100% of itself. So something's already happened, we've knocked 15% off. As I say, before anything happens to a value, you always start with 100% of it. So if 15% comes off, how much is left? 100, take away the 15% that's been knocked off, 85% is left over. So what that means is, after the voucher's used, there's still 85% of a price to pay. And so rather than paying 100% of the bill, you're paying 85% if you have a voucher, which is obviously less than the full 100%. And so what it says here is that after using the voucher, the bill for a meal is £27.20. And so £27.20 doesn't represent the full original total. That's 85% of the original value. We need to work out from 85%, we need to work out the original price, which was 100%. As I've said before now, the original price is 100% of itself. So what can I do to go from 85 down to just 1%? Once I can work out 1%, I can multiply by whatever I want to. Well, the answer is any number divided by itself gives us 1. And so we can divide 85 by 85, which gives us 1%. But to keep the balance, I need to do the same to the other number. So £27.20 divided by 85 will tell us what 1% of the cost is. So divide by 85, we'd have 32 pence. So 32 pence is 1%. To go from 1% up to 100%, all we need to do is just multiply by 100. Because 1 times 100 is obviously 100. But if we do that to one side, we need to also multiply the other side by 100. So 0.32 times 100, that will tell us that the original 100% value of the bill was £32. And so for 26 part B, our final answer would be £32. Question 27, so we're nearly at the end of the paper now. Part A, it says to rearrange a formula v equals u plus at to make t the subject of the formula. This sounds more complicated than what it is. But when it says make t the subject, all that means is we want to write this formula not as v equals something, but as t equals something. And so what we want to have is t on its own at the first bit of the equation. Not v first, but write it t first. So I'm going to do this a couple of different ways. The first way I'm going to do is over here. So you can treat this as solving an equation really, but just trying to get t on its own. And so what we could do is move this u away. So just got at on its own on the right hand side of v equals. Now that u is positive. So that means if we swap its side, we'll swap its sign. What we're actually doing is we're taking away one u from each side of the equation. But it looks to me like it's swapping side and swapping the sign. So opposite of a positive u is minus u. And so on the left hand side, what we'd have now would be v minus u equals at. Now at means a multiplied by t, and we want to have t on its own. So because that a is multiplying the t, when we swap the side to the left, it will swap from being a multiplier to a divider. Swap side, swap sign. And so then on the left we'll have v minus u, all of that divided by a, equals t. So that means we're nearly there. Only thing here is t doesn't come first, and so if we just switch around the order this is written in and write it t first, we'd see that t equals v minus u all divided by a. So that's the formula in terms of t. So v minus u all over a. So this is one method. With the answer being, where t is a subject, is this here. I'm going to show you another way, as I promised. A different method we can use for these is to write down the letter or the thing we want to make the subject first, and then ask step by step what happens starting with the letter. And so t comes along, what's the first thing that happens to t? Well, t bumps into the a. The first thing that t interacts with is the a, which multiplies t. At means a multiplied by t. So we multiply by a. After multiplying by a, that's when we add u on. Nothing else really happens, so all of that must equal v. Now what we do is we go the opposite way round and work backwards on ourselves, rewinding this till we get to t at the beginning. So start with v at the end, but now we're going to be going the opposite way, and so we're going to be doing the opposite things. Opposite of adding u is subtracting u. And then here, the opposite of multiplying by a would be to divide by a. So if we just piece this together now, v take away u is v minus u. And the final step is we're doing v minus u, all of that divided by a. And so now, because t is in line with what it's equal to, we can say that t equals v minus u divided by a. And that, again, is our final answer. We need to write it t equals whatever. In this case, t equals v minus u divided by A. Part B, we now need to complete this table with consistent metric units. So it says metric, it means we're not talking about miles or yards or feet and inches. It means meters, kilometers, kilograms, and so on. Now one of these you should find quite straightforward. The other is a bit trickier. Now speed, if the distance is in meters and the time is in second, speed is distance divided by time. So in terms of units, that's meters per second. m/s. Now in physics they also write this differently. I'm not going to confuse you by saying how they write it, but that's the main way I want you to write it, m/s. And acceleration means meters per second per second. So this is a harder one to get your head around. That's meters per second squared. So speed is one I'd expect you to get. Acceleration, a bit of a harder one to contextualize, but acceleration units, if distance is in meters, times in seconds, the acceleration unit would be meters per second squared. Now we're on to the last question. It says multiply out and simplify x minus 8 squared. Now what's being squared? It's the whole bracket. So what this means, and what I'd suggest you do is write this out, is it means the bracket x minus 8 multiplied by itself. Now the reason I'm suggesting you write this out twice is because if you don't, a common mistake here is to just look at this and think, oh, that's x squared, take away 8 squared, which is 64, but it's not. So once you've got to this stage, I'll show you two common ways. I'll show you my favoured way first because I'm a bit biased, I suppose. So my favoured way is to write along the top one bracket and write down the side of a table the other bracket. In this case, because the brackets are the same, we're going to write x minus 8 along the top and x minus 8 down the bottom. What's going to be happening is you're going to be multiplying each thing above by each thing to the side of the box. So first of all, x multiplied by x is x squared. Then here, x multiplied by 8 would be 8x, but because that's a minus 8, it'll give us minus 8x. In the same way here, x multiplied by another minus 8 would be minus 8x. And take care here, minus 8 multiplied by minus 8 would give you positive 64, plus 64. That's a calculator paper, so if you're not sure, do feel free to use your calculator to check a minus multiplied by a minus. But minus 8 multiplied by minus 8, I can just show you here. Plus 64. And so the final thing we do now is to group together all these terms I've written down in blue. So x squareds are one thing. X squareds are different to normal x's. Normal x's, the non-x squareds, we're taking away 8 here, and we're taking away another 8 of them over there too. So just to colour code slightly, got 1x squared. Now the x's, we're taking away 8 here, and we're taking away 8 over there. So if you take away 8 and then take away another 8 after, you're taking away a total of 16 x's. And finally, just writing down the number on its own. The number which comes on its own is just plus 64. And so our final answer is it's x squared minus 16x plus 64. Now, I did mention another way. This was the way I was taught by Mr. Riley from Birmingham. He taught us actually FOIL. So you might still be aware of FOIL. what FOIL means I don't really like this method, but maybe you do, so I'm going to mention it anyway. If you're multiplying out a bracket with two things in by another bracket with two things, you can always think of it in terms of FOIL. Now, F stands for first, so it means the first thing you're multiplying. So the first thing in each bracket is an X. O stands for outside. So the outer bits of your bracket. So in this case, the outer bits are the X and the -8. I stands for the inner bits, the inside parts of the brackets. If these bits are the outer parts, the inner bits are here. Finally, L stands for last. The last things in each bracket, which in this case, the last thing in the first bracket is -8. The last term in the final bracket again is -8. And so what we can do here is just write down what the first thing is, what the outside thing is, what the inside is, what the last thing is when we multiply them together. Now, as I say, the answer's already been done for us. This is just an alternative method. You only need to use one method. You don't need to do the question twice. So the first thing, x times x would give us x squared. The outside bits, the x multiplied by -8, which should give us -8x. The inside bits, here, is -8 multiplied by x, which would give us another -8x, and multiplying the last bits of the bracket by each other, a -8 multiplied by -8, again, would give us +64. Then in the same way as before, it's just a case of grouping together the like terms and simplifying down. So once again, you should find we'd have an x squared, a total of taking away 16 x's, and plus 64. So using a different method, you should get the same result. And that's question 28 done, and therefore the entire paper. Hope you found at least some of it useful. Keep working hard, keep asking your teacher for more practice, keep revising at home, and never give up, and you should hopefully get the grade you're needing. Thanks for listening, and I'll see you next time.